For example 1, I'd like to sketch a graph of the function y equals 2 to the x. So this is a brand new function that we really haven't encountered before, where our variable is now in the exponent. In fact, we call this an exponential function. If we come up with a table of values, just to keep it really simple, we're going to put numbers in place of x, simplify it, and then I'll try to plot those as best I can. So maybe I'll go -2, -1, 0, 1, and 2. So I'll start with 0. So, 2 to the 0 is going to be 1. 2 to the first is 2. 2 squared is 4. I could put another one on here for 3. 2 to the third power is 8. If you plug in negative values, maybe I'll jot those down here. 2 to the -1 just means 1 divided by 2, or if you'd like a decimal, that's 0.5. If you do 2 to the -2, that's going to be 1 over 2 squared, or 1/4, and that's 0.25. And if you get the gist, I'll just jot, okay, this is 0.5, this is 0.25. So that when I plot these, okay, I'll do it in red. If I start with 0, I get 1. If I go over to 1, I get 2. If I go over to 2, I now get 4. So this is what it means, like, for exponential, it's growing at a faster and faster rate. If I go over to 3, I'm up at 8. And if I go in the other direction, let's see, if I go to -1, I get a half. If I go to -2, I get a quarter, and the numbers are going to keep getting closer and closer to 0. They never actually equal 0, but they go closer to it. The function that goes through these points would look something like this. On the other side, it's going to kind of disappear on me, but I just know that it goes forever to the left. It's just getting smaller and smaller and smaller. So you should definitely plot this in Desmos and kind of check it out. But one thing that happens here is that there's a horizontal asymptote of y is equal to 0. So that is, on the axis here, the graph gets closer and closer to y equals 0 as we approach -infinity. But it still is true that the domain is all real numbers. You can put any number that you'd like to in place of x, but the y values that you get back are all positive. That is, it goes from 0 to infinity. You never get 0, and you never get a negative number. So this is a basic graph of an exponential function. Just a couple key features. It starts growing faster, it's always positive, and there's a horizontal asymptote at y is equal to 0. So to compare a different type of exponential function to our previous example, I'm switching what we call the base. In the previous example, the base was 2. If I change it to a half, something different happens in this function. I don't think it's going to be too much of a surprise, but we can still take the approach of plugging numbers like -3, -2, -1, 0, 1, 2, maybe 3 into this equation to see what we get. If we start with the negative numbers, so let's say I take my function of 1/2, but I put a -3 in place of x, that negative just flips the fraction to a 2 to the +3, which is 8. And if you continue this for -2 and -1, again, all this is going to do is flip the fraction and square it. It'll then flip the fraction and then raise it to the first. So my values are 8, 4, that should be a 2, and then 1. Anything to the 0 power is going to be 1. Whereas now, if you put in +1, +2, and +3, you're going to get your 0.5, your 0.25, and I believe your 0.125, numbers that keep getting closer and closer to 0. So it still is true that the domain is going to be all real numbers. You can put any number that you'd like to in place of x, but you're never going to get a negative value or 0. You just get things that get really close to 0. And this means that there's a horizontal asymptote at y is equal to 0 again. But the difference here is, at -3, you get +8. At -2, you get 4. At -1, you get 2. At 0, you get 1. At 1, you get a half, then 0.25, then really, really close to 0. So it's the same graph, it's just increasing in the opposite direction. So same function, it's just like flipped around. In fact, it's a transformation over the y-axis, a reflection. One reason why that actually happens is if you have 1/2 to the x and you change 1/2 to 2 to the -1 and then you multiply the exponents, you can write it with a base of 2, but you're switching the x to a -x, which we saw flipped your graph over the y-axis. You don't really need to keep that in mind when graphing different types of functions. The only thing to really note is if your base is a number like 1/2, basically anything between 0 and 1, your graph is going to decrease. But if you have something like 2 to the x, where your base is bigger than 1, then your graph is going to increase. So if you had like 1/3 to the x, I know the graph is more going to resemble this. Whereas if I had 5 to the x, that's going to look like the graph in our first function. So as a final part to this lesson, in example 3, I want to sketch a graph of 2 to the x minus 3 plus 1. And currently labeled on the graph as a dotted equation is the graph of 2 to the x. So if you understand a basic exponential function, then you also understand something more complicated if you switch out maybe x with an x minus 3, or if there's a plus 1 at the end. If I look at this equation of 2 to the x minus 3 plus 1, I'm thinking this is left 3 and up 1, but the same type of graph. So maybe I'll start by placing in what I think the horizontal asymptote is, which is going to be, it's not going to be 0, but I know it's now going to be y equals 1. And I'll just choose a couple of points on this graph, like where they move. Everything is going to move 3 places left and then up 1. So like this point here, it goes over 1, 2, 3, and then up 1. So I get this spot right here. This is 3, 2. So I'm going to plot that. Let's see, maybe I'll get a couple of others on here. Let's see, here's the point 1, 2. Again, this goes over 3 and up 1. So I get a point here at 4, 3. And maybe I'll just pick one more. Let's see. Perhaps I'll choose this point. This is 2, 4. So again, this is going to go over 3 and up 1. So I get this spot at 5, 5. And I'm just looking for a basic sketch, but it should resemble the graph that I started with. So it's going to have this exponential growing faster look. And I know it has to approach this horizontal asymptote. So like here's a sketch of the graph, and you should check this in Desmos to make sure it actually matches up to what you think it is. Maybe just a couple other features are the domain and range. So here the domain, it still is -infinity to +infinity, but now the range is from 0 to infinity. So if you see a more complicated exponential function, you should still be able to understand it based on transformations.